Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome my dear student. Mrs. Manal Salahuddin with you. Today I will explain lesson 2, Unit 4, Part 1. This lesson is positions of point and straight line with respect to a circle. Let's start. Firstly, I will start from position of point with respect to a circle. Point and circle. We have 4 positions. This is the first one. If I have circle M and point A in its plane, to determine the position of this point, point A, to respect to circle M, I will compare between the length of the radius of the circle and the distance between M and A. That means I will compare between MA and the radius. As we can see here, MA is greater than the radius. Therefore, point A lies outside the circle. When MA greater than the radius, A lies outside. That means the length of MA belongs to interval R and infinite. Okay, R and infinite. R open. Why R open? Because I can't take the value of R because ME greater than R. Okay, this is the first one. The second position here, circle M and point A. If MA equals R, then A is on the circle, belong to the circle. Okay? The third position. Now, as we can see here, point A or the length of MA is less than the radius. MA less than the radius. Okay? If MA less than radius, then A lies inside the circle. Inside. When MA less than R. That means MA belongs to 0 and R. 0 and R. 0 closed. That means 0 is me. And R open. Okay? The fourth position, if point A on the center, that means the length of MA here equals 0. If MA equals 0, then point A lies on the center of the circle. Let's summarize the 4 positions of point with respect to a circle. First one, if MA greater than R, then A outside the circle. Second one, if MA equals R, then A lies on the circle. The third, if MA smaller than R, then A inside the circle. The last position, number 4, if MA equals 0, therefore A lies on the center of the circle. That means if I want to determine the position of point with respect to a circle, I will compare between MA and radius. Okay? Drill. If circle M with radius length 4 cm and A is the point in its plane, okay, then complete each of the following. Number 1, if MA, the distance between the center and point A, equals 4 cm, then A is dots the circle M because dots. I said before, if I want to determine the position of point with respect to a circle, compare between MA, the distance between the center and the point, and the radius. Here, in first one, the distance MA equals R equals 4. Therefore, this point on the circle. Why? Because MA equals R. Number 2. If MA equals 2 root 3, then A is, to determine the position here, convert 2 root 3 into decimal form to know if 2 root 3 more than 4 or less than 4 or equals 4. Of course, 2 root 3 is less than 4, less than the radius. Therefore, A is inside the circle. Why? Because MA smaller than R. Number 3. If MA equals 3 root 2, then A is, now 3 root 2 is greater than R, greater than 4. Therefore, point A outside the circle. Why? Because MA greater than R. Number 4. If MA equals 0, MA equals 0, then A, yes, is on the center of the circle, lies on the center. Okay, the second part of our lesson today. The position of straight line with respect to a circle. Now, I determine the position of a straight line with respect to a circle. Also, we have 4 positions of straight line with respect to a circle. First one, here I have circle M and straight line L. How to compare between, or how to determine the position of this straight line with respect to a circle? I will compare between, yes, I will compare between the perpendicular distance from M and the straight line, the perpendicular distance MA with R. Okay, here MA is greater than R, therefore L is outside the circle. MA greater than R, therefore straight line L intersects circle M equals phi. There is no intersection between them. So straight line L is outside the circle. This is the first position. That means MA belongs to interval R and infinite. The second position. Here I have circle M and straight line L, and ME equals R. The perpendicular distance between the center and the straight line equals R. So, in this case, straight line L intersect circle M at point A, and straight line L is called tangent of the circle, tangent of the circle, and point A is called point of tangency. Remember that the tangent of the circle is perpendicular to the radius from point of tangency. As we can see here, the straight line perpendicular to the radius from point A, from point of tangency. Third position. Circle M and the straight line L cut the circle at 2 points. As we can see here, MA is less than R. MA less than R. Okay? So, this straight line intersect circle M at 2 points. Then MA smaller than R, when MA smaller than R, therefore straight line L intersect circle M at 2 points X and Y, and straight line L is a secant. Straight line L here is called secant. That means MA belongs to interval 0 and R. 0 and R. 0 closed and R open. Okay. The fourth position. Here I have circle M and straight line L passing through the center. That means MA equals 0. If MA equals 0, so this straight line is called axis of symmetry of the circle M and intersect the circle at 2 points X and Y. Okay, and the line segment XY is called diameter of the circle. Now, let's summarize the four positions of straight line with respect to a circle. Four positions. First one, if MA greater than R, therefore the straight line is outside the circle. If MA equals R, therefore the straight line is tangent of the circle and perpendicular, this tangent perpendicular to radius of the circle from point of tangency. Okay, the third position, if MA less than R, therefore this straight line is called secant of the circle and intersect the circle at 2 points. Okay, and the last position, if MA equals 0, therefore the straight line is axis of symmetry of this circle. Now we'll solve this drill. If circle M with radius length 7 cm and line segment ME perpendicular to straight line L, where A belongs to L, then complete each of the following. Number 1, if MA equals 4√5 cm, then the straight line L, here he asked me to determine the position of this straight line with respect to circle M. So I will compare between the length of MA and the length of the radius in each case. In this case, 4√5 will be greater than 7. When we convert into decimal form, we'll find 4√5 greater than 7. Therefore, this is straight line outside the circle. Number 2, if MA 3√7, here we'll find 3√7 is less than 7, less than the radius. Therefore, this straight line is secant of the circle. Number 3, if 2MA minus 5 equals 9 cm, then the straight line L. Now, I will compare between, in each case, I will compare between MA and the length of the radius. But here, I don't have MA. I have equation 2MA minus 5 equals 9. So, we must find MA, the value of MA. So, solve the equation. 2MA equals 9 plus 5. 2MA equals 14. Then MA equals 7. So, MA equals 7 and the radius equals 7. Yes, this straight line is tangent of the circle. Number 4, if the straight line L intersects circle M and MA equals 3x minus 5, then x belongs to, I said before, if the straight line L intersects circle M, that means this straight line is a secant, okay? So, MA belongs to interval from 0 to radius, to less than the radius. From 0 to less than the radius. So I will substitute 0 instead of MA, then I will find the value of x. The value of x here will be equals to 5 over 3. And I will substitute by value of r 7 instead of MA. And I will find the value of x. So x belongs to interval 5 over 3 and 4. Number 5. If the straight line L tangent of circle M and MA equals x squared minus 2, then x belongs to, now, straight line L tangent, okay? Then MA equals R. So I will write 7 instead of MA, then solve the equation. The answer will be x belongs to -3 or 3. Now another drill. M is a circle in each of the following figure and AB straight line is tangent of this circle. Complete. Number A. This is the given. This is the problem A. And he asked me to find measure of angle AMB. What is angle AMB? Let's see. Okay. I want to find measure angle AMB. Now, I said before, any tangent perpendicular to the radius from point of tangency. Therefore, measure angle A equals 90. Now, I have exterior angle with measure 125. This exterior angle of the triangle MAB. Therefore, 125 equals this exterior angle equals the sum of interior angles of the triangle non-adjacent. So, measure angle AMB equals 125 minus 90. Okay, now measure angle AMB equals 35 degrees. Number B. He asked me to find measure of angle ADB. Angle ADB. Okay, now ADB, this angle. Okay, here I have tangent AB and AM radius. Therefore, measure angle MAB equals 90 degrees. Okay, in triangle MAB, angle A 90, angle B 30. Therefore, angle AMB equals 60 degrees. But this angle is exterior angle of triangle AMD. AMD. Therefore, 60 equals the sum of angle D and angle MAD. But the two angles D and MAD are equals. Why? Because the triangle MAD is isosceles triangle because MD and MA are two radii. Therefore, measure angle D equals 60 divided by 2. So, measure angle ADB equals 30 degrees. Number C. Now, he asked me to find the value of angle AME. As we can see here in this problem, AB straight line is tangent of the circle, okay, and AB tangent of the circle M, and the measure angle B 50, okay. Now, I want to find measure angle AME, this angle. Okay, let's see the given. AB is a tangent and MA is a radius. Therefore, measure angle A equals 90 degrees. What about angle E? CD is a chord of a circle and E is a midpoint of this chord. So ME perpendicular to CD. That means measure angle CEM equals 90 degrees. Now I have quadrilateral BEMA and I have angle B 50, angle A 90, and the angle AE equals 90 also. Therefore, to find measure angle EMA, I will subtract 360 minus the sum of 90, 50, and 90 degrees. Then measure angle AME equals 130 degrees. Now, example number 1. M is a circle and AB straight line is a tangent of this circle. Find the parameter of figure ABMD. The parameter of ABMD. This figure, this quadrilateral MBAD. To find the parameter of MBAD, I want to find the four side length of this quadrilateral. I have MD and AB. What about MB and AD? I don't know. So I need to find the length of MB and the length of AD. Now, look at triangle MAD. D is a midpoint of the chord AC. Therefore, MD perpendicular to AC. Therefore, measure angle D is 90 degrees. So I can find the length of AD by using Pythagoras theorem. I have the hypotenuse and I have the length of MD. So AD will be equals to 4 centimeters. Now, what about the length of MB? Look at the triangle MAB. Triangle MAB also right angle triangle. Why? Because MA is a radius of the circle and AB tangent of this circle. Then measure angle A equals 90. So I can find the length of MB by using the Pythagoras theorem also. Now let's see the steps. In circle M, AC is a chord and D is a midpoint of AC. Therefore, measure angle MDA equals 90 degrees. Therefore, triangle MAD is a right angled triangle. Now, the length of AD equals 4 cm. Since AB straight line is a tangent of circle M and measure angle MAB equals 90, therefore, the length of MB equals 13 cm. Okay? So, the parameter of ABMD equals 32 centimeters. Now, the last example, example number 2. Here I have problem in the opposite figure, and I want to prove that straight line AB is tangent of circle M. Now, how to prove that straight line tangent of circle? To prove that AB straight line is a tangent of a circle M, we must prove that measure angle MAB equals 90 degrees. Why? Because MA is a radius. And when measure angle MAB equals 90, that means this straight line perpendicular to the radius. Therefore, this straight line is a tangent of the circle. Okay? Now, how to prove that this angle was measured 90 degrees. Now, look at triangle ACM. ACM here, AM equals AC, but AM equals MC, 2 radii. Therefore, this triangle is equilateral triangle. That means each angle of this triangle equals 60 degrees. Now measure angle MAC equals 60 degrees. Now measure angle ACM equals 60 degrees also. And this angle is exterior angle of triangle ACB. So this angle ACM equals the sum of two interior angles non-adjacent, the sum of angle A and angle B. Okay, but angle A and angle B are equal in measure. Why? Because CB equals AC. AC equals CB. Therefore, measure angle A equal measure angle AB. Now, the measure of angle BAC equals 60 divided by 2. Then this part or this angle equals 30 degrees. Now 30 degrees plus 60 degrees equals 90 degrees. Let's see the steps. The proof. In circle M, since AM equals AC and AM equals MC, therefore triangle AMC is an equilateral triangle. That means measure angle MAC equals measure angle CMCA equals 60 degrees. Okay, measure angle MCA, angle CMCA is an exterior angle of triangle ACB and AC equals BC. Therefore, measure angle CAB equals 60 degrees divided by 2 equals 30 degrees. Now measure angle MAB equals 90 degrees. Therefore, straight line AB is tangent of circle M. Thank you for watching. See you later in a new lesson. Mrs. Manal Salahuddin was with you. Assalamu alaikum wa rahmatullahi wa barakatuh.